Alright, so since I didn't get a test grade yet, hopefully I'll get them graded tomorrow, but then I was thinking maybe I could just wait till Friday, so then your homework on Friday is the test grade, but that was cool. We have 2 days of section 2-1 and section 2-1. So either we'll have the test back tomorrow or we'll have the test back. But chapter 2 is called polynomial power and rational functions, which means a lot of stuff that we do in chapter 2, we'll review some of the stuff. Like we've already talked about rational functions, we've already talked about quadratic functions at some point. I don't this way. But you're going to see some of that same algorithm stuff. Alright? You do the review after you take the test, Justin. That doesn't really help your test score, right? Well, unfortunately, the test comes with 100 points. All right, polynomials. Every polynomial function can be written in this lovely form, which I've actually written out for you before. But basically, we just start with some extra power, and we usually go down in descending order. So again, if you want something without letters, that would be like f of x equals 3x to the 4th minus 2x cubed plus 7, right? Normally, that goes down one at a time, but it doesn't have to fill in all of them. We usually end with a constant if there's a constant in the problem. Really important that you know that the n, the highest power, is the degree of that polynomial. And the number in front of that highest power is your leading coefficient. Yes? So far, so good. Oh, the exponent cannot be negative because it's not a polynomial, right? That's true. So here's part of the work today. Determine if the function is a polynomial function. If so, state the degree and leading coefficient. Seems like maybe that there's a lot of homework problems today, because I think there's like 12 or something. But some of them are just 6. So number 1, is number 1 a polynomial function? Yeah, it's a linear function, but linear functions are still polynomials. So what is the degree of this? 1, because the exponent is 1. I'm just going to put LC for the coefficient. And the leading coefficient would be, right, not the first number, but the number in front of the highest x. Normally we write them in descending order, but they don't have to. What about number 2? Is number 2 a polynomial function? No, that's not.
Yes.
A little crazy, a little crazy. I added an x to the 0 right next to that. What's anything to the 0 power? 1. I think the 0 power is 1.
No.
Except for 0 to the 0 power doesn't exist. Did you know that? Here we go. Here's a little proof for you. 0 to any power equals 0. So following this power, or following this pattern, it seems like that 0 to the 0 power should equal 0. Yes? But think about other numbers. If I took 2 to the 3rd, I get 8. 2 to the 2nd, I get 4. 2 to the 1st, I get 2. So following this pattern, we're dividing by 2 every time. So this would be 1. So everything but 0, when you follow the pattern, that to the 0 power equals 1. But then 0 to the 0 power, you're like, it equals 0? So it doesn't exist. It's undefined. If you try it on your calculator, it says error. Because if you go like this, oh, well, 3 to the 0 equals 1, 2 to the 0 equals 1, 1 to the 0 equals 1, so following this, it seems like 0 to the 0 should equal 1. Well, it can't equal both, so it just doesn't exist. It can't do it, I'm telling you. So any number to the 0 power except 0 equals 1. So anyway, people think this is not a polynomial function, but it's just a constant function. So it still is a polynomial function, it just has degree 0. So this is degree 1, this is degree 0. So it's a trick. Why put it on? It's kind of, I don't know, the book says there is no leading coefficient because technically 13 is a constant, not a coefficient. I think you could argue that if x is 0 is there, you could say that it's 13, but your book says it's made by the book, right? So I would say that. What about number 3, Justin? Is that a polynomial function? I asked you because you told me that I skipped over on the previous page that to be a polynomial function, the degree has to be a whole number, which means a positive number, no fractions. Couldn't you write this as x to the negative 1? That's the same as 1 over x. That's a negative exponent. You can't have negative exponents, you can't have fractional exponents to be a polynomial. So this is not a polynomial. I asked you because you're the one that told me. Okay, don't yell at the answer. Which of the following is a polynomial function? So only one of them should be a polynomial function. So think for a minute, and then you're going to do this when I tell you. It's one finger, A, B, C, D. Ready? Which one's a polynomial function? 3, C, I mean, because this one is dividing by x, so that's no. This one is a negative exponent, second divided by x. This one has a square root of x, so yes, you're all right. Alright, so the other thing we want to talk about is writing equations. Linear functions are polynomial functions, so I want you to be able to write a linear function. If I gave you this in function notation, where f of negative 1 equals 2, and f of 2 equals 3, and I said write a linear function, what do you need to find? Slope. Linear functions have slope, so you have to find the slope between these 2 points, but you could graph it, but I hope that you would just do the formula. Just a little reminder, which one of these is the x and which one of these is the y in this? Right, this is x, this is y. So this is like the ordered pair, negative 1, 2, and this is like the ordered pair, 2, 3. So step 1, I'm going to find the slope. Good old rise over run, y's over x's. The y's is the rise, remember? Say that a lot, you get really confused. The y's is the rises, the y's is the rise. The rise is the y, so you can remember it's not the top, but so 3 minus 2, 2 minus negative 1 gives me a slope of 1/3. Yes? Now what do? I want the equation. You remember this equation? It's point slope form. I think it's the way to go when you're writing equations, because if you have a point and you have a slope, you just plug it in. Your other option is good old mx plus b. You can plug your slope in, but you have to plug in your point, x and y, and solve for b. You can do that. But I think this is easier, and then you can get it in this form if you want. Because you can pick either one of those points. It doesn't matter. When you put it in slope intercept form, we'll get the same answer. So what do you think? Negative 1, 2, or 2, 3? 2, 3. Alright, so I'm going to plug in 3 for the y, and I'm going to plug in 1/3 for my slope, and x minus the x, which is 2. So x1, y1 is your point, your slope right here, And then if it just said write an equation and it wasn't multiple choice, or it had just a complete blank rewrite it, that is an equation. So that's another reason I like point for, because you can get your answer, like you get your points for that. What I found out in calculus, they usually have it as y equals, so you have to solve for y. You don't necessarily have to put it in slope-intercept form, but you could just add 3 over here, right? So you could say y equals 1/3 times x minus 2 plus 3. Or if you really want, could you distribute and put that in slope-intercept form? You could, but you don't. Yeah, I mean, you want to read the directions on the homework, right? If it says write in slope-intercept form, then you need to write in slope-intercept form. But in calculus, they have to write a lot of equations, and theirs are always kind of like y equals and then the box. And so they can write it like this. Alright, so linear functions, hopefully you feel somewhat good about linear equations, right? You feel like you're doing that your whole life. You don't know what life is like. Okay, so the other thing we want to talk about is quadratic, which we've talked about. Quadratic formula, we've talked about solving a quadratic, but we want to talk about using the vertex form of a quadratic equation. So remember that this is called standard form, right? This is what we use for factoring, this is what we use for the quadratic formula. This is called standard form. But we also, and I think in Algebra 2, I don't remember in Algebra 1 if you did vertex form, I don't think you did. We can also write it in vertex form that looks like this. Do you have any big memories of that? So there you go. You are? I know, right? Maybe you should do it. Michael Crossman turned his test in yesterday and said that was the first test he'd ever taken in his life. And he got an A+ on the previous test. So I was like, oh. Well, the worst math test. So I don't know. I haven't graded that. Maybe I'm very frustrated and worried that they're all going to be great. That's it. Well, I'll tell you that precalculus is usually the equalizer effect. Usually, especially second semester. Bradley Schrader did the same thing in Excel, I think. Bradley Schrader had a pretty rough grade of pre-cal for a while. This is the first year. And they both the tests were okay, but they weren't enough to really get that fast. Mason Coleman had to retake pre-calculus, which he played that game. There's lots of people that play that game that end up retaking pre-calculus. Graham Carr, who's one of the brightest kids I ever taught, I got my first 5 up there in 2011. Pre-cal had a D for a while because he wasn't doing homework. Still didn't want to do his homework, so had a rough grade. But they got 5 on calculus because he did his homework. So it's okay if you can do it without doing homework, but I'm telling you, pre-calculus. Okay, back to it. Vertex form. It's called vertex form because you can tell the vertex of the quadratic by just looking at the equation. So if you have it written like this, your vertex will always be H and K. Think about your transformation rules. The number on the outside moves it up and down. The number on the inside moves it left and right. And then your number in the front is a stretch or a shrink. So that's kind of why this works. If A is negative, it opens down. If A is positive, I think it's going to come back to you over the If A is equal to 0, it is not a quadratic function anymore because that means 0 times anything will be 0, right? So A is not going to be equal to 0. Okay, so really nice if it's in quadratic form, which a lot of these homework are. It just says, like on the homework, it's like pick the right graph. But it says describe how to transform the graph, and then sketch it. Okay, over on your test, right? So, because we have a +3 out here, what does that mean? That doesn't mean when you have a number outside.
Oh.
So that's moved up 3. And because we have a -2 on the inside, that's moving which direction? And then a 2 in the front is going to stretch our graph. And you're so right. It's a vertical stretch by a factor of 2. So, I also know, based on vertex form, that my vertex is h and k, which is 2, 3. Notice I didn't do -2 because the formula is x minus h, right? Yes. So normally my vertex is at 0, 0, but because I moved it right 2 and up 3, that's why my vertex is at the point 2, 3. And again, if you don't do well with the stretches, you can just make an XY chart here. But I know that normally, if it wasn't stretched by a factor of 2, when I go over 1, I go up 1. I'm just going to double that, because I'm multiplying that by a factor of 2. When I go over 1, I'm going to go up 2 on each side. And normally, if I go over 2, I go up 4, so I would double that. If I went over 2, I would go up 1, 2, 3, 4, 5, 6, 7, 8. Again, should feel very familiar to what we did on the test yesterday. Hopefully. The homework online also talks about that axis of symmetry. You remember what the axis of symmetry is? It's that line that cuts down the middle, and it's always just x equals whatever that first coordinate is, right? So if it asks you for the axis of symmetry, it's an equation, and it's just x equals whatever that line is. That line that you could cut down a parabola and fold it over. So if you want to go back on this previous page here, you could write axis of symmetry is the line x. Okay, but they're not going to all be that easy, right? Because what if it's not in this form already? You want to be able to put it in that. Look at this. Rewrite the equation in vertex form, state the vertex and the axis. So we want to put this in the form a times x minus h squared plus k. Which means we want to take something that's not a perfect square and make it a perfect square. How do we do that? It sounded like a what? Oh, no, I know this. Complete the square. To take something that's not a perfect square and make it a perfect square, we have to complete the square. Which is why, since the beginning of this class, I've been forcing you to complete the square, right? This is one of those places that you can't get out of this by doing the quadratic formula. Because we're not solving this, we're just trying to rearrange this side so that it looks like that. I'm not getting a solution, I'm just rearranging it. So you have to complete the square here. Normally when I complete the square, what do I do with this 5? Normally I move it over here, right? But I can't move it over here because that's y. So, you have to leave the y over here. So what I'm going to do is I'm going to leave a little space to complete the square, and I'm just going to kick that -5 down there. Push it to there. Technically, here you could, but then you have to subtract it back in, so I got there. Think about how this kind of works. So you have this number hanging out there anyway. And now I have to complete the square. What do I do to get that number? You take half of b and you square it. So half of 4 is 2, and 2 squared is 4. Yes? Normally, when we're solving equations, if I add 4 here, I have to add 4 over here, right? I can't do that, so I have to think about what could I do on the same side to undo adding 4. Yes. So because I can't add it over here to keep it balanced, I just have to undo what I did on the same side. So if I add 4 and then subtract 4 back, I'm still all equal. But I did do something. I've kept it equal, but I've made it so I can rearrange this. Because now, can I write this as a perfect square? Yes. That factors into x plus 2 squared, because it's always half of that middle number. And then minus 5 minus 4 gives me a minus 9 on there. So I've kept it equal by undoing it, adding 4 and subtracting 4. Like I haven't changed the value of it, but I'm able to manipulate the equation to make it look like vertex. Cool, right? So the reason that we like vertex form is now looking at this, can you tell me what the vertex of this equation would be? Right? So h is going to be the opposite side of what's in there. K is going to be the whatever sign is there. So it is negative 2, negative 2. You got to put it in that equation. So vertex form makes graphing really easy. I didn't say you had to graph this, but think about if you did have to graph this. Now that you know the vertex, there's no a in front of there, which means we haven't stretched it any. So you just go to negative 2, negative 9 over 1 up 1, and you can make your graph very quickly and easily. I will actually x equals negative 2. I'll tell you what happens on tests and quizzes. People say axis is negative 2, and then they miss a point because they didn't write it as an equation. So x equals negative 2. As it's an equation, it's a line, not it's a point. Okay, let's do a harder one. I'll put a video on Classroom about this. Not that anyone ever watched it. It makes me feel fun. No, I don't mean like if you're here, you don't have to go back and rewatch my notes. But I sometimes put little short videos, like less than 10-minute videos from a YouTube guy explaining the same thing but a different way. In like 8-minute videos. That's what I do. Do your homework and you're like, I don't know what to do with it. Just watch videos. That's all I'm asking. What? Why does this one look scarier? Yeah, because when we complete the square, we're not allowed to have the 2 in front of it. If this was an equation that we were solving, what do we normally do with that 2? Normally we divide everything by 2. Can I take f of x divided by 2? No, I cannot. Which means, here, I'm going to do a couple steps here. Step 1 is I'm going to separate the x's again from the 7. So the 7 is completely separate. Leave a spot, put the plus 7. 7 does not get to do what the other parts do. 7 is excluded from our club. So, I cannot divide by 2, but what else could I do to take 2 out of that? Start with the f. With that. It always works. It's always that. When Mr. Gardner always says his dad was a math teacher, he always says it's tough. About 4 words there. 4 words. So I'm going to factor the 2 out. And if I factor the 2 out, again, I haven't changed anything. I just rearranged some stuff. I'm not going to factor the 2 from the 7 because the 7 is excluded from our club. Wait until I see one. This is a very big deal in Algebra 2 that you're supposed to teach this in Algebra 2. Usually at least one of you in here is like, yeah, I kind of remember that, but you're all like, no. I have a first
well, it'd be like constantly getting things out.
He was like, you guys, I want to keep looking at like that. He's like, look at your watch today. Alright, so I have to complete the square here. We've had this discussion a lot about decimals versus fractions. I'm fraction friend. I have to take half of 3, which to me is much easier to take half of 3 like this. And then I'm going to square it. So I'm just going to get 9 over 4. Yes? So I'm going to put 9 over 4 there. If you want to take 1.5 and square it, 0.25. Right, but b is now 3, not 6. You have to do it after you factor the 2 out, which is why you can't complete the square unless the x squared by itself. So you have to factor first, and then the new middle term is what I'm taking out. Okay, so now this is where it's going to get crazy, especially because you've never done this before. So, Sean says, because we added 9/4 in here, we have to subtract 9/4 out here. Yes, that's what we did last time? But, think about this problem. Is that really just 9/4 all by itself? Or if I worked this out, would I really be multiplying 9/4 by something else? You can see that 2 in the front? So if you factor something out, you have to think about that that's really 2 times 9/4. So to subtract 9/4, you still have to multiply by that 2, or subtract 18/4 in the problem, because you have to keep it balanced. Last time we didn't multiply anything in front, so we didn't have to do that. You can really blame Mr. Gressick on all your bad grades, I guess. Tyler. Because I had 3 in the middle, right? So half of 3, yes. And so you could do 1.5 if you want, and square it. So if you did it as decimals, you'd get 2.25 here, which is the same thing as my fraction. But I always just put it over 2 and square the complement. It's a lot in one line, right? That's all one line on your paper. There's a lot of thinking going on. Okay. So, now we're just going to clean it up. We still have this 2 here. The whole point of this, completing the square, is so we can write that as that perfect square, which is half of that middle number. This is a plus 3, so it's going to be plus in the middle. If it was a minus there, it'd be minus in the middle. And you can put 1.5 there, or I'm going to get pretty nice. And then on the outside, be really careful. Here's what happens every year. People take 7 minus 9/4, and then they multiply by 2, which is not the correct order of operations, right? If you type this all at once in your calculator, it should just work. Or you can just work it out without a calculator, but just be careful when you're doing that, because that's really 7 minus 9/2, right? Which would be like 14/2 minus 9/2, which would be 5. Or 2. Does that look like vertex form? So my vertex is the opposite side in here, so negative 3/2, comma, 5. Let's take it. Look, I think I don't have this, right? That's it. What would the x's and the b? The good and bad part of the online homework is that you're going to know if you're right or wrong, right? Please look at those resources that view an example or help me solve it. Maybe if you feel really lost on this, do the help me solve it first. Then you can do a similar question that doesn't take place from that. Alright? Please see me outside of class. No one ever comes to see me anymore. You tell people every morning that I would want extra help. No one ever does extra help. Bring your computer and say, I did this one twice already and I missed it and I don't know whether you're wrong. Help me with this. I'll be happy to help you with it. You have to be trying this stuff, especially since you've never done it before.
Oh, we don't need help.
It's okay. So I'm here every morning, like every 5, you're welcome to come in. And ask for help. I'm here after school, you're welcome to come and ask for help. My friends said that you're anything like I don't know if you or not, but you're welcome to come in and ask me for help. Looking at your computer, or it might be kind of like that, but maybe as you're doing some of this homework, you're out of your paper that you're short work on, so that if you miss it, I can get the work that can help you. Even if I have the test graded tomorrow, we